Hello everyone, welcome to our structural design masterclass. Today we want to learn how to calculate concrete cover for structural members. Now, basically, concrete cover for structural elements are determined by fire resistance, fire resistance, which is also linked up with the exposure exposure condition. Now, what does fire resistance actually mean? Fire resistance is actually a process in which a concrete cover is provided for a structural element. And if, for instance, there is a fire outbreak, it will take a particular numbers of hours before the fire can get to the reinforcement. You know that reinforcement is very weak. It's very weak in high temperature. So the moment the reinforcement is exposed to fire, it heat up, and we want the temperature rise. There's a tendency for that reinforcement to be weakened, and that building can actually collapse. So when you are designing your structural elements, there are some elements that you will provide maybe 25 cover. There are some elements that you provide 20 cover. There are some elements that you provide 25 cover. So we want to know the basic of how you can calculate your concrete cover, a kind of an empirical formula which Eurocode has actually put in place that will help us to calculate concrete cover. So the first thing that you have to consider when you want to provide a concrete cover for your structural element is that you have to consider the concrete strength. What strength of concrete are you going to use for your structure? What strength of concrete are you going to use? Now, the next thing that you will consider is exposure condition. Exposure condition. Exposure condition. Eurocode 2 table 4.4, table 4.1 has actually, list out the exposure condition. So let's quickly go to Eurocode 2 and see Eurocode 2. This is Eurocode 1. So let's go to Eurocode 2 and see some of the conditions that have been listed out. This is Eurocode 2 part 1. Eurocode 2 part 1. Okay, Eurocode 2 part 1. Table 4.1. Table 4.1. Table 4.1. Table 4.1. Table 4.1. Okay, so here we have table 4.1, exposure classes related to environmental condition in accordance with EN 206 part 1. So here you now have the class designation. You have the description of the environment, informative example where exposure classes may occur. So for number 1, no risks of corrosion or attack. So you now see the description of this environment is that for concrete without reinforcement or embedded metal, all exposure except where there is freeze, thaw, abrasion, or chemical attack. For concrete with reinforcement or embedded metal, very dry. So this is the condition. This is the environmental condition. If you want to apply this class of exposure, Now here we now say that concrete inside building with very low air humidity. Okay. Then number 2, corrosion induced by carbonation. Corrosion induced by carbonation. So we now have this class XC1. XC1, dry or permanently wet. Dry or permanently wet. Now, concrete inside building with low air humidity. Concrete permanently submerged in water. So, for you to apply this class of exposure, it has to meet up. For instance, now, like the building, the normal residential building, it's either it is dry or permanently wet. You know, it is either dry or permanently wet. So when you look at the condition, it actually occur in some of these residential buildings that it is either it is dry or maybe the building can be permanently wet. So the building under this are concrete inside building with low air humidity, concrete permanently submerged in water. So we are using XC1 for this. XC1 for the dry or permanently wet. Okay. So here we have that the nominal cover C norm. This formula for nominal cover C norm is equal to C mean plus delta C D EV. Okay. So let's go back to our code to see what some of these actually mean. Okay. What is actually mean? So this is where we derive the formula. This is where we derive the formula. Eurocode 2 clause 4.4.1 plus 4.4.1. So here they have taken time to explain to us what each of these mean. So C mean is actually the minimum cover. The minimum cover. But when you have this subscript B, it means due to bond requirement. Due to bond requirement. C mean due simply mean minimum cover due to environmental condition. Due to environmental condition. C clause 4.4125. Then this one, additive safety element, plus 4.41.26. Then delta C door, reduction of minimum cover to use of stainless steel and this. Okay. So here we now have that the C norm is equal to this formula, where C mean is equal to max of that. Now, considering the C mean and this, the one that is the maximum, that is what we are going to adopt. So C mean B, minimum cover due to bond, is equal to minimum cover due to bond. So which has to do with the diameter of bar. So in this case, we assume that we are using, 12 mm diameter of bar. So the C mean do minimum cover due to environmental condition. Assume, sorry, please. Okay. Assume X1 and using C20, 25 concrete. So we have this to be 15. Okay, so let's see how we arrive at that 15. Look at, so it has already been provided here that the nominal cover, reinforcement and pre-stressed concrete inside XC1. So we have this to be what? To be 15. That is 15 is the C mean due to environmental condition. C mean due to environmental condition. So it is 15 that has been provided. Now, this will now be added to the allowance in design for deviation, which is your delta C depth, delta C depth, delta C depth. Now, let's look at the code. Why we have this thing. Let's look at the code. Let's look at, okay, fine. This is the formula for it. He said the greater value of C mean satisfying the requirement for both born and environmental conditions shall be used. So C mean will now become max of this C mean, then C mean dure plus this minus this, or add 10 to it. Now, all these things that we have that is being calculated here is what we have as our 15. We have it as what? As a 15. This plus this. Okay. So here, therefore, C norm will now become C mean plus the allowance in design due to deviation. So assuming there is no measurement of cover, so we now have this to be 10. We adopted 10. So when you now add the 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 C mean due to environmental condition and allowance in design for deviation, we now have 10 plus 15 plus 10, which give us what? 25 as our cover. Okay, so we have to check for adequacy of section for 1 hour fire resistance. This is actually 60 seconds, which is 60 minutes, which is what? Which is 1 hour. So thickness of the thickness H mean is 80. Thickness H mean is 80. Now for 1 hour, the thickness of this is actually is 80. Look at where you have this. The slab thickness H mean is 80 for 1 hour. Now, if you are designing one-way slab, the axis distance A is 20. But if it is two ways, and this two-way has a condition that your Lx over Ly over Lx must be less or equal to 1.5, or 1.5 is less than Ly all over Lx is less than equal to 2 for you to use this 10 as your axis distance. Now, let's look at how the axis distance is being calculated. When you look at this is how we calculate the axis distance. Now, the axis distance is actually from the center of the diameter of the reinforcement. So this is how you calculate your axis distance. So code has already made provision, has given us this axis distance. So what we just need to do is that we just put in the diameter of the reinforcement. So in this our case, our diameter is what? Is 12. So for you to check the adequacy of this, what we need to do is that the H mean for 1 hour is what? Is actually 80. 80 of 175. Remember that we propose one. Okay, in this case we propose 175. It may be, let's say let's change this to like, let's change this to 150. Let's change this to 150. Okay, so our axis distance A mean is equal to 20. Now, how do we get this 20? This is where we got the 20. This is where it is assumed that it was one way. So the axis distance here now become what? 20. So that is how we got the 20. Now 20 of 25. The 25 is actually our C norm. That is the nominal cover for that reinforcement. So when you calculate, when you put this 25 plus the diameter of reinforcement divided by 2, so you now have what? You now have your axis distance, your actual axis distance to be what? To be 31, which is, that is not critical. Therefore choose C norm to be what? To be 25. Okay, so in a situation where you now say, okay, I'm changing my concrete strength to 30 stroke 37. 30 stroke 37. Remember that this 30 is your cylinder, is your cylinder strength, while the 37 is your cube strength. So you say, okay, I'm changing it to 37, and let my exposure condition XC2, wet, really dry. Okay, so in this case, what you need to do, you can still maintain your concrete, your diameter of reinforcement. Maybe you can change it. Let's change this to 16. Change this to 16. So when you change this to 16, when you change this to 16, so let's see what they have provided for us. So let's go back here and check what they have provided for us. Now you see that what they have provided for us here is 25. Is 25. No, okay, yes, is 25. Is 25 plus delta C deviation, 25. So that is why we have 25 here. Remember that the first one was what? 15, which we got it from here, 15. But in this case, because we have changed our concrete grade to 37, so the formula is 25 plus this. So this give us 25 plus 10, which is what? 35. So you now see that because the concrete grade has increased from 20 stroke 25 to 30 stroke 37, you now discover that the this thing, the concrete cover has equally changed to what? To 35. Now in this situation, we are using 1.5 hours for fire resistance. 1.5 hours for fire resistance. So H mean is what? Is 100. So let's look at it. Remember, this is what? 1.5 hour. So H mean is what? Is 100. Then let's just assume that it is we are using one way. Let's just assume that we're using one way. So this means that our axis distance is what? Is 30. So we go back here. Axis distance is 30. Axis distance here is 30. Is 30. So this will now become this plus half of what we have. So this gives us 43, which is not that critical. So we providing C norm of 35 is adequate. So that is how you can calculate your concrete cover for your structural element. So in a situation where you will see maybe we use 25, we use maybe 20, we use 35, I don't want you to be confused. I think you can now know how we derive at all those calculations. Okay, thank you very much, and see you in our next video.